Given that the cubic equation 2z cubed plus 3z squared minus 5z minus 4 is equal to 0 has roots alpha, beta and gamma, find the equation that has roots 2 alpha plus 3, 2 beta plus 3 and 2 gamma plus 3 using the method involving sums and products of the roots. Now there are two methods for doing these type of equations. This is probably the long-winded approach, but we'll have a look at it. And then in the second video, I'll do the other approach and then use a GeoGebra app to sort of support it. Okay, so you've got 2z cubed plus 3z squared minus 5z minus 4 is equal to 0 with roots alpha, beta and gamma. So the sum of these roots, alpha plus beta plus gamma, the sum of roots is minus b over a, so it's going to be minus 3 over 2. The product of the pairs of roots, alpha beta plus beta gamma plus alpha gamma, I like to write it that way around because it's in alphabetical order, is equal to c over a. This is the shorthand version for that. So c is going to be minus 5 and a is 2. And then the product of the roots, alpha beta times gamma, is going to be, that's equal to minus d over a, so it's going to be minus 4 over 2, so it's 4 over 2, which is equal to 2. Just be careful with the minus signs. Right, the new equation has roots 2 alpha plus 3, 2 beta plus 3, and 2 gamma plus 3. So the sum of the new roots, you can see why it's going to become a bit tedious, is going to be 2 alpha plus 3 plus beta plus 3 plus 2 gamma plus 3. So that's going to be 2 with alpha plus beta plus gamma plus 9. And then we know that alpha plus beta plus gamma is minus 3 over 2. So 2 times minus 3 over 2 plus 9. And that gives me 6. Right, the product of the new roots in pairs. So it's going to be 2 alpha plus 3 times 2 beta plus 3 plus 2 beta plus 3 times 2 gamma plus 3, 2 alpha plus 3 times 2 gamma plus 3. So using a plus b times a plus b, so it's going to be 4 alpha beta, 2 times 3 alpha will give you 6 alpha, 3 times 2 beta will give you 6 beta plus 9, and then repeating that process for each of these. It gives you 4 beta gamma plus 6 beta plus 6 gamma plus 9, and repeating it for that gives you 4 alpha beta plus 6 alpha plus 6 gamma plus 9. So that's going to give 4 for the pairs of roots alpha beta plus beta gamma plus alpha gamma plus 12. Now it's 12 because you got 6 plus 6, that gives you 12 alpha. You got 6 beta plus 6 beta, that gives you 12 beta. And then we've got 6 gamma plus 6 gamma, which gives you 12 gamma. So it's 12 times the sum of the roots, which is plus 27. The values of that was minus 5 over 2, and the value for that was minus 3 over 2, and that gives plus 27, which actually gives an answer of minus 1. The final case is where it gets a little bit difficult because you have to now multiply 3 brackets together. Right, so I'm going to keep that one and then multiply these two. So it's 2 alpha plus 3, and then I'm going to do 2 beta times 2 gamma plus 3, plus 3 times 2 gamma plus 3. You have to be very careful because it's very easy to make a mistake. So you get 2 alpha plus 3, so that's going to be 2 beta gamma, so it can be 4 beta gamma plus 6 beta plus 6 gamma plus 9. Now doing 2 alpha times that bracket plus 3 times that bracket. Be careful not to miss something out. Okay, just writing that out again. Then going through, we're going to get 8 alpha beta plus 12 alpha beta plus 6 alpha gamma plus 18 alpha, and then we're going to get 12 beta gamma plus 18 beta plus 18 gamma plus 27. So we've got 8 alpha, beta, gamma from there. And then we're going to have 12 of the pairs, alpha, beta plus beta, gamma plus alpha, gamma. And then we're going to have 18 of the sum of the roots. 18 alpha plus beta plus gamma, and don't forget the plus 27 on the end. Putting the numbers in, we go 8 times 2 plus 12 times minus 5 over 2 plus 18 times minus 3 over 2 plus 27. That gives an answer of minus 14. So for equation with new roots of minus b over a will be equal to 6, c over a is equal to minus 1, d over a is equal to minus 14. Now you can take a can take on any value, but we'll let a be equal to 1 because these are all integer values. So, and the general format of a cubic is az cubed plus bz squared plus cz plus d is equal to 0. So from this, a is 1, so we get, and b is minus 6, because minus b will be equal to 6, c will be equal to minus 1, and d will be equal to minus 14, which means d is 14. So a possible equation will be z cubed minus 6z squared minus z plus 14 is equal to 0. Okay, so this has been a video to show you how to form a new cubic equation using the idea of sum and products of the roots. In the next video, I'll give you an alternative method for doing it and then relate it to a GeoGebra app. I hope you've understood, and I thank you very much for watching.